Well, our next question is sideband frequencies in the carrier wave. Carrier wave is a radio wave, frequency 10 to the power 13 hertz. But when we speak sideband frequencies, it means the neighboring frequencies of the carrier wave. Just the bandwidth of AM wave is 2 FM, where FM is the modulating frequency. So what is our next question? That is, we have to explain sideband frequencies in carrier wave. We have to justify that bandwidth of amplitude modulated wave is 2 FM, that is twice the modulated frequency of the modulated wave, where FM is the modulating frequency. So the concept is sideband frequencies and bandwidth of the amplitude modulated wave. So sideband and the bandwidth, there is a range of the frequencies, and that is called the bandwidth. So the equation number 1, which we have formed earlier, it shows that AM wave, amplitude modulated wave, is the sum of 3 sinusoidal waves. So we have to add all the 3 sinusoidal waves, and that will be the amplitude modulated wave. Now, the original carrier wave of amplitude is AC and frequency FC. So it is written as omega c over 2 pi. Because omega c is 2 pi FC. From that we have calculated FC, and FC is equal to omega c over 2 pi. Now, amplitude spectrum of the amplitude modulated wave. When we use the term spectrum, we are referring to different frequencies. So, in the extreme left figure, where we have written mu AC over 2, mu is the modulation factor. It is multiplied by amplitude of the carrier frequency divided by 2, and that is equal to lower sideband. So, lower sideband will be FC minus FM. So, if we take the difference of the carrier frequency and the modulated frequency, that gives the lower sideband. The carrier frequency is represented by AC. So FC is the carrier frequency and A is the amplitude of the carrier frequency or the carrier wave. Similarly, USB, the upper sideband, that is given by FC plus FM, that is carrier frequency and adding to it modulated frequency, and that is given by function mu AC over 2, where mu is the modulation factor. The second wave of amplitude mu AC over 2 and of frequency FC plus FM, as shown earlier, the sum of carrier frequency and modulating frequency is called the upper sideband frequency. This is I have explained earlier. So upper sideband, when we speak, we take into consideration the addition of carrier frequency and the modulated frequency. Now, amplitude spectrum of amplitude modulated wave. So it is again reviewed. That is again interpreting the same thing. That is the difference of FC and FM gives the lower sideband, and the addition of FC and FM gives the upper sideband. And the carrier is represented by FC, and the amplitude of the carrier frequency is represented by AC. The third wave of amplitude mu AC by 2 and frequency FC minus FM, the difference of carrier frequency and modulating frequency, that is FC minus FM, is known as the lower sideband, that is LSB, shown in the figure. So extreme left is a lower sideband, and that is the difference of the carrier frequency and the modulating frequency. And it is represented by mu into AC by 2, where mu is the modulation factor. The difference between the highest and lowest frequencies present in the amplitude modulated wave is called its bandwidth. So bandwidth, when we speak mathematically, we have to take the difference of FC plus FM and FC minus FM. So in this process, we will find FC will cancel off and the bandwidth will become double of the FM, where FM is the frequency modulation or modulated frequency. Hence, the bandwidth of amplitude modulated wave is twice the frequency of the modulating signal. Either say modulating signal or say the modulating wave, that is all the same thing.